Welcome to an example of graphing the tangent function using the unit circle and the reciprocal identity tangent theta is equal to sine theta divided by cosine theta. So on the unit circle, it's equal to y divided by x. Now there are several ways to graph the tangent function. This is just one of them. And we'll focus on graphing the tangent function from negative pi over 2 to positive pi over 2. So we're looking at this interval here. So let's go ahead and set up our coordinate plane. We'll have pi over 2 here and negative pi over 2. Remember, it's always helpful to divide this interval into 4 equal parts. This will be negative pi over 4 and positive pi over 4. Let's call this 1 and we'll call this negative 1. So now we'll take a look at key angles in this interval and then plot the function values on the coordinate plane. And we'll determine those function values by taking the y-coordinate and dividing by the x-coordinate, as we see here. Let's start by taking a look at 0 degrees or 0 radians. Y divided by x would be 0 divided by 1, which is equal to 0. So here's one point on the graph of y equals tangent theta. Now let's take a look at pi over 4 radians, or 45 degrees, and negative 45 degrees, or negative pi over 4 radians. At pi over 4 radians, notice the x and the y coordinates are equal to each other, so y divided by x would be equal to 1. So at pi over 4, tangent theta is equal to 1. And at negative pi over 4 radians, notice how the y coordinate is negative, so the tangent function value would be negative 1 here. Now let's see what's happening at pi over 2 and negative pi over 2. At pi over 2, y divided by x would be 1 divided by 0, which is undefined, and therefore tangent theta does not exist at pi over 2 radians. And the same is true at negative pi over 2 radians. And that's actually where tangent theta has vertical asymptotes. So we have a vertical asymptote at pi over 2 radians and negative pi over 2 radians. And this should actually be enough information to make a decent graph of y equals tangent theta on this interval. We know it's going to pass through these 3 points and then it will approach the vertical asymptotes. So from here we can make a nice sketch of y equals tangent theta on this interval. It would look something like this. And of course, if we needed more points in this interval, we could just select different angles and then determine the value of y divided by x. So if you know your unit circle, this is a nice way to remember the graph of y equals tangent theta.